Okay, modulus equations. So you need to make sure that you start with the modulus part just on one side of the equation and everything else on the other. So if you've got something like this to begin with, you just need to move the 6 across, the negative 6 across, so that you've just got a modulus graph on one side. And now what you do is you solve the equation twice. Once treating it as a positive and the second time treating it as a negative. So first of all, I just write out x cubed plus 3x equals 4x plus 6, ignoring the modulus sign. Or on the other half of the page, same equation, but this time with a negative. The negative can be on this side or it can be on this side. Watch out because it's a negative for the whole side, so you need to think of this as being in a bracket and both signs become negative here. Don't forget, a negative times a negative would give you a positive sign. You then solve these two equations in the usual way. They're both quadratics. That one gives you these two values as answers if you want to check, and this equation gives you these two answers as values if you want to check, but you solve it in the usual way as a quadratic. Some solutions may not be valid, so what you often need to do is to use the graph to help you decide which of these values you need to use. So if I look at this one here, the graph I've got is x squared plus 3x. So if I draw the modulus graph of x squared plus 3x, I'd factorise, those are my key values, and this is the shape of the graph. Drawing the graph is often part A of the question. And on the other side, I've got 4x plus 6. So if I draw in 4x plus 6, it looks something like this. So then if I look at my solutions, I've got one solution here, and I've got another solution, although it hasn't met here. If I were to continue the graphs, there would be another solution up there. The other possible solutions I've got would be if I took the modulus of this and I reflected it in the y-axis, or if I thought of it as not having the modulus graph and put this underneath. But if you can see, if I look at sort of the modulus graph, there would be another solution up here somewhere, and there would be another solution on this bit. So they're the four possible solutions which link to these four possible values. And looking at the ones I've got, this would be the negative 6 value, this would be the negative 2 value, so this one is going to be the value of negative 1, and this one is going to be the value of x equals 3. So my solutions for this are x equals 3 and x equals negative 2. Solve both equations, get all of your values, and then the final step is just to use the graphs to check that they're right. But this is the really important bit here, where you're separating and solving it as two separate equations.